in this video, we will see a problem on calculation of maximum and minimum intensities of stresses for a masonry wall, and that masonry wall is also called as a chimney. And for that, here we have a question. It is given that find the maximum and minimum intensities of stresses at the base of a uniform circular chimney having external diameter 2 meter, internal diameter 1.6 meter. It means the chimney is hollow circular in section. So I'll write that in the data. Here it is a hollow circular section. Next, the question is to find the maximum and minimum intensities of stresses. We have to calculate what is sigma max and sigma min. That is maximum and minimum intensities of stresses at the base of a uniform circular chimney having external diameter as 2 meter. So I'll denote it as capital D, 2 meter. Internal diameter is small d, 1.6 meter, and height 25 meter. When it is subjected to a wind pressure of, here the wind pressure is given, which I'll denote it as P suffix W, as 1.5 kilonewton per meter square. Next, the density of the chimney material may be taken as 78.5 kilonewton per meter cube. This density is the weight density. I'll denote it as small w. Weight density is 78.5 into 10 raised to 3. I will convert it into Newton per meter cube. So now with the data available, let us try to get the solution to this problem. Now when we start the solution for such a problem, the best way is to start with the help of a diagram. So here I'll draw the diagram of a chimney. Now the cross section is given. It is circular in cross section, and here we have a hollow circle. So I'll draw that cross section as well. So here is the cross section and it is a hollow circle. So I'll have to draw another circle which will be inside. This is the hollow cross section of the chimney. I'll be projecting this internal circle. Now, here is the masonry wall which is given in the problem. And it has hollow circular cross section. Now, here the external diameter, I'll denote it as capital D. Then there is an internal diameter which will be small d, and it is given in the question that when it is subjected to a wind pressure, it means on one side of the chimney there will be wind pressure. So here I am denoting the wind pressure. this will be the wind pressure, which is given as, in the problem it is 1.5, and I have denoted it as P suffix W, 1.5 kilonewton per meter square. Now, for this kind of a problem of a masonry wall on which over one side there is wind pressure, we need to calculate the maximum and minimum intensities of stresses. So what we are going to do here is, at first I'll get the area, cross section area for the circular, hollow circular section. I'll say that since the cross sectional area of masonry wall is given by capital A, it is equal to pi by 4 outer diameter square minus inner diameter square. I'll put the values here. Therefore, capital A is equal to pi by 4. Capital D, it is given as 2 meter, and internal diameter small d is given as 1.6 meter. So therefore the answer of area comes out to be 1.13 meter square. Now, after getting the cross sectional area, with the help of the weight density given, we can find that how much is the load which is acting on this masonry wall because of its own weight, that is its self weight. So that we can calculate, but in that we would be requiring the volume. So here I'll say that after finding the area, therefore volume of masonry wall, that is V is equal to area into the height of the chimney. Now this height I'll denote it as H. Now if we look into the problem, this height H is given, it is 25 meters. Here it is given, I have denoted here with capital H, so even here I'll make it as capital H, and this value is 25 meter. So now here we'll get the volume of the masonry wall, and therefore that volume is equal to area into length, area into the height of the chimney. Area was 1.13 and height is 25 meters, so the volume is 28.27 meter cube. After getting the volume, I can use the relation of volume and weight density to get the total load which is acting because of the own weight. I'll write down, since the load acting on the chimney, which is nothing but masonry wall, because of its self weight, is given by, now I'll denote that load as W, and that will be equal to the weight density multiplied by volume. Therefore here the weight density is given 78.5 into 10 raised to 3, 78.5 into 10 raised to 3, it is Newton per meter cube, and the volume is 28.27. So multiplying this, I'll get my answer of weight, which is 2.22 into 10 raised to 6 Newton. Now this much is the weight which is acting on that masonry wall, and with the help of this weight there will be compression, because the load which is acting on the masonry wall, because of its self weight, that load will be axial, and because of that there will be compression in the masonry wall. So direct stress will be induced, and that direct stress will be of compressive nature. So here I'll write down that since because of self weight of the chimney, direct stress will be induced in the section. So therefore the direct stress will be of compressive nature, and hence the direct stress is the total weight upon cross section area. So here we can see that the weight is acting over the cross section area, and therefore direct stress will be weight we have calculated just now. It was 2.22 into 10 raised to 6 Newton, area 1.13. So from this the direct stress value, it comes out to be 1963, that is 1963.89 into 10 raised to 3 Newton per meter square. Now after getting the direct stress value, I need to find out bending stress. Now how will bending stress will be introduced? Here if we look at the figure, because of the self weight there is compression, but because of wind pressure there is a force acting which would try to bend this chimney, bend this masonry wall in the direction of wind pressure. So now since the wind pressure is given, with the help of that we can calculate the wind force which will be acting exactly at the half of its height. So here I'll denote that wind force as F suffix W, and we can see that this wind force would be acting on the projected area, that is outer diameter into H. So here I'll say that also because of wind pressure there will be wind force acting on the face of the wall, and hence bending stress will be induced because of wind force. So therefore wind force F suffix W is equal to wind pressure into the projected area. Now what is projected area? Now here we have a rectangle whose width is equal to the capital diameter, which is outer diameter, as 2 meter, and this height is equal to 25 meter. So this area would be called as the projected area, and projected area is the area on which the wind force acts. It is not acting on the cross section but acting on this height and external diameter. So this wind force will be, if I look from the top, it will be up till here. This would be the wind pressure, and because of that there is wind force. So I'll find the value. That will be, therefore, F suffix W is equal to, wind pressure is given 1.5 into 10 raised to 3. I'll convert it. It was given in terms of kilonewton per meter square. Here it was kilonewton per meter square. I have converted it into Newton per meter square into the projected area, which is 2 into 25. So from this I'll get the value of wind force, and therefore F suffix W, it comes out to be 75 into 10 raised to 3 Newton. Now this wind force will be acting at exactly half of the height, that is, if the height is capital H, exactly at half of that there will be the wind force at h by 2 distance. So now I'll say that, therefore, bending moment produced because of wind force will be, I'll write it onto the next page, that bending moment will be the moment produced at the base, and it will be wind force into half of height. The wind force is 75 into 10 raised to 3 and height is 25, so half of that. So here I am getting the bending moment which is at the base. It is 937.5 into 10 raised to 3 Newton meter. Now after getting the bending moment, I'll calculate the section modulus for the section. Because of the wind force there is bending stress induced, and in that I will require the section modulus. So I'll calculate that. Now after this, since section modulus for given cross section, it is given by Z is equal to pi by 32 capital D raised to 4 minus small d raised to 4 upon capital D. This is the section modulus formula for a hollow section where capital D is outer diameter, small d is inner diameter. So therefore I'll put the values here. Capital D is 2, small d is 1.6, so raised to 4 divided by 2, and therefore the Z answer is 0.463 meter cube. So now after getting the section modulus, we have bending moment and here we have section modulus. We can calculate the bending stress because of wind force. So therefore bending stress induced in the section because of wind force, that will be given by sigma b is equal to m by z. So here I'll put the values. Bending moment is 937.5 into 10 raised to 3. Z is 0.463. So here I'll get the value of bending stress, and that comes out to be 2.024 into 10 raised to 6 Newton per meter square. Now after getting the bending stress value, here I'll get the value of maximum and minimum intensities of stresses. So I'll write down, therefore maximum intensity of stress at the base is given by sigma max is equal to sigma d plus sigma b. Sigma d was 1963.89 into 10 raised to 3 plus sigma d b we have found out, that is bending stress, 2.024 into 10 raised to 6. Adding up the values gives us sigma max. It is 3.99 into 10 raised to 6 Newton per meter square. Therefore, the minimum intensity of stress, sigma min, will be direct stress minus bending stress. Direct stress is 1963.89 into 10 raised to 3 minus 2.024 into 10 raised to 6. So here I am getting sigma min as minus 60.11 into 10 raised to 3 Newton per meter square. As I see, one answer is positive and the other is negative. The meaning is that if we have a masonry wall, because of the wind force, there are chances that in the direction of the wind force, this chimney, it will bend, and when this bends, here I am drawing the diagram to explain it in a more clear manner, that when this chimney would bend, here at this corner it will get lifted, and when this gets lifted, this portion is stretched. So at this point there will be tensile stress, and the section which is pressed to the ground, which is here, there will be compressive stress. So this is the first chapter in which we take compressive stress as positive, because it will be pressing the masonry wall against the ground, and tensile stress we take it as it is the minimum stress and taken as negative. So here the value which we have, sigma max, it is at this corner. I'll say that these are A and B. So at B, here we will get sigma max, because it is compressive stress. The answer is positive, sigma C. And here at A, it will be sigma minimum, which is tensile stress, because here the chimney gets lifted and then this masonry wall falls. And with this we complete the question.